Hello and welcome to this webinar on RoPax weather deck fire protection. My name is Johan Roos and I work for Interferry. This webinar is being recorded and it will be shared after as a YouTube clip. Also, the presentations made will be available at the LASH fire website. The background to this session is the extensive work carried out at the IMO following several RoPax fire casualties. This work is set to be finalized by the subcommittee SSC9 now in March. As the Interferry Trade Association, when we represent the industry at the IMO, we are always very cautious when it comes to retroactive requirements, meaning that operators will have to modify their existing ships. In this case, however, we have found that not having any requirements for detection and suppression of weather deck fires on RoPax ships is an unacceptable risk, and we have actively supported that a new and realistic requirement is introduced. To that end, today I will soon hand over to Martin and our colleagues at DFDS to frame the issue for us, then moving on to John Garner of Interferry to talk about the IMO developments. We will after that move on to detection by inviting Rick from FIKE to give his presentation, followed by suppression undertaken by Roger James of Unifier. During this session, you have the option to put questions to us in the interface, and we will wrap up towards the end with addressing a few of those questions, and the ones we do not have time for, we will deal with in writing afterwards. So by that, please be welcome to this webinar, and I will ask Andrea to hand over to Martin.
Thank you very much. So, assuming that my screen is now visible, my name is Martin Karlsson. I work for Stena Teknik and especially on fire safety issues. We will hear from the operator side, me and Jakob Lynge from the DFDS, show you some few examples from our, let's say, accident history in the RoPax industry and RoRo industry, where it would have been an advantage to have fire water monitors on weather deck. So please, Jakob, start with the first example here.
Thank you very much, Martin. And I'm Jakob Lynge from DFDS, as Martin said. I'll start up with the case of Britannia Seaways from back in 2013, where she sailed a trip with military cargo off the Norwegian coast. The ship is not a very long ro-ro cargo ship, and the cargo that caught the fire was placed on the weather deck in the most forward part of the ship. Next slide, please. Oh, sorry, the foremost slide, sorry, a bit too fast. As you can imagine from this picture, which is taken from the bridge, heavy rolling did occur in the rough weather. There were 9 flat racks with jerrycans on the weather deck. You can see 7 of them here in the row facing towards the bridge, all of them containing petrol and jet fuel. Next slide, please. Due to heavy rolling and by that shifting cargo, some jerrycans were leaking, and sparks ignited the jerrycans with fuels. As some of you can see from this picture, also taken from the bridge, severe fire broke out and huge flame were on the weather deck, making it very hard to fight the fire as a firefighter on board with normal fire equipment. The firefighters fought the fire with for a very long time from both starboard and port side. They got wet, cold, and it was quite exhausting and demanding task for the crew. So they asked the 12 passengers on board to assist them, and luckily they were all military personnel taking care of the cargo. and they did volunteer for the task. From the bridge and to protect the accommodation, they use sprinkler for the windows and fire hoses for cooling down the accommodation on the forward part of the ship. Next slide, please, Martin. Back in 2010, a fire broke out on board the Lisco Gloria, which is a ro-ro passenger ship. They were trading between Kiel and Klaipeda. During that voyage, the trailer were checked for temperatures during the voyage, and it was done all physically by the crew. During an inspection, one crew member could smell some burning stuff. He could not identify where the sources was, and short after the smoke detector alarm sounded on the bridge from the garage. And the garage is the 5 larger holes in the gray area beneath the white superstructure that that Martin is pointing out here. Next slide, please. The captain ordered the power supply switch off for the transport unit and activated the trencher system, a system that was released unsuccessfully. The firefighting team were unable to fight the fire due to thick smoke, and around 15 minutes after the fire broke out, the captain ordered the Lisco Gloria evacuated. The fire on the upper deck had already spread across the whole garage area at that time. The emergency team were ordered to proceed to starboard lifeboat and take measures to cool the ship's side using a number of fire hoses. Next slide, please. And as you could see from this picture, it ended up with a constructive total loss. The crew could not fight the fire due to different items. Yeah, thank you very much, Martin.
Yes, and another commonly mentioned example is the Norman Atlantic, where there was a fire on the open rudder deck underneath the weather deck. And in this case, the fire on the weather deck containing cars was a secondary fire, let's say. And that is quite common if you scroll through the different examples we have here. The Sorrento was a similar case where we had a fire, let's say, downstairs that influenced in a second phase the weather deck. And in such a situation, the water monitors on weather deck is very useful for containment and the boundary cooling of the deck plate and preventing the fire to spread from deck below to units located on weather deck. Same situation on Und Adriatic back in 2008, which at a later fully developed stage of the fire looked like this from the air, and there were attempts to with firefighting planes to put water on the ship like this, with also here a constructive total loss. Lately, we have the Euroferry Olympia, also there with the root cause probably downstairs and fire on the weather deck as a secondary effect. In previous fire safety projects, such as Fire Safe 2, the fire monitors on weather deck was let's say, evaluated and concluded to be efficient measures, mainly based on the boundary cooling effect containing the fire. Okay, let's say that we are faced in the industry by with putting installing those water monitors on board. We have various things to consider. we could use either manual operated water monitors and locate them in the leftmost picture here on existing structures that will give a sufficient reach and coverage over the deck. In some cases, we might be forced to add structures like this to get sufficient reach and reach over the cargo, because that is of course important to reach above any trailers or cars located on the deck. We could also go for the remotely operated monitors, where there are more freedom to put them on existing structures where there is no operational manual access needed. Other considerations that needs to be done is to look at the coverage, and there would be, let's say, formulas on how to calculate this coming as well to our, let's say, support. I think John later on will tell more about what is coming in terms of rules here. Okay, so that was basically all from my side.
So good afternoon, everybody. My name is John Garner from Interferry. Good afternoon, everybody. I'm assuming you can see my screen now. I'm going to talk about the IMO developments. As Johan mentioned, IMO will finalize the amendments to SOLAS Chapter 2.2. First through the session at SSE 9 in March, and that will be then verified by the MSC committee in June. This has been going on already through last year's meeting in March, and some of these draft amendments are already agreed, and they will be finalized in the upcoming March meeting. So first we look at the major modifications for new ships, which in square brackets is proposed to come in from 1st of January 2026. So there are weather deck. The weather deck will be included in functional requirements for new ships. There will be independent identifiable fixed fire detection and fire alarm systems for rural spaces, and fire control system in special category spaces at all times. There will also be a video monitoring system in vehicle special category and rural spaces, with continuous monitoring to be stored for 7 days.
John, we seem to have some technical issues with your presentation. Yes, that looks good now.
Yes, I'm sorry. I think we are good now. So that was the first slide. I'll just move to the second slide. Is that okay, Johan? You can see the second slide?
That's okay. Please carry on.
Good, thank you. So again, this still relates to new ships. Planned to come in from 1st of January 26, with additional structural fire protection for special category spaces, if subdivided within internal decks, the mezzanine decks. Arrangements for openings in RoRo and special category spaces were a point of great discussion. Those openings will be permitted if protected by a closing device, but they're not to be permitted under survival craft, emergency generator, and in way of intakes from the engine rooms. There has been a planning to work out a safety distance for weather tech intended for the carriage of vehicles, and fire monitors will be required for new ships on the weather deck, and suitable signage to give easy identification of the sections of the fixed fire extinguishing system will be required. If we now move to existing ships, the requirements are much less, and the plan here is that in square brackets to implement from 1st of January 2028. And the things which will or are very likely to go forward are, again, the fixed fire detection and fire alarm systems with smoke and heat detection in special category open and closed RoRo spaces and vehicle spaces, fixed fire monitors on the weather deck, and effective video monitoring system, but with a replay function for at least 24 hours. Some ships may already have that installed, but only for a limited period. So it was agreed that would be for 24 hours on existing ships. There are consequential amendments to the FSS code. New ships, those amendments would be from 1st of January 26, and existing ships from 1st of January 2028. So the dates are aligned. And the items here are specifications for fire monitors on weather decks, new combined smoke and heat detector specifications, new visible and audible fire signals, and engineering specifications for linear heat detection systems. And that concludes a summary of the upcoming IMO rule development.
Very good, John. Thank you so much for that. Now we have framed the issue and we have talked about the developments. So let's move into the solution side of things. Rick, East Coast, North America somewhere. Good morning.
Houston.
Let's hand over to you.
Thank you, Johan. Rick Jeffress with Fight Corporation. You see my screen okay?
Yes, we can see your screen, but we cannot see you, Rick.
Okay, should be able to see me now.
Excellent, thank you.
All right, thank you. So I'm Rick Jeffress. I'm with Fight Corporation. I handle business development for flame detectors, video analytics, and thermal radiometry. We'll be talking about these detection products on shipboard applications. So what we'll be talking about today is the weather deck detection overview. We'll talk about each type of technology. We'll provide the negatives and the positives of each technology. The technologies that we'll be discussing today are multi-spectrum triple IR flame detectors, thermal cameras, which are thermal radiometry, video analytics, and combination systems including video analytics and a thermopile element. So the issues that we run into on weather decks are a large space. The detectors are required to cover a large area to reduce the amount of detectors required on the vessel. We also have the environment, rain, snow, water, ice. All the detectors are required to be able to withstand these elements, not corrode, continue to work. And if they do have an obstruction on the lens that alleviates their ability to detect, they need to be able to send a trouble signal to the fire alarm system so the crew can clean the detector. We have vehicle obstructions. So as you can see in this image, any fire that occurs between the vehicles may not be detected by the detector. So we want to make sure the detectors are placed in such a manner that they have visibility to as much of the deck space between the vehicles as possible. So they should be mounted high. Moving hot vehicles, when this is particularly troublesome for thermal radiometry. So that's an issue that we need to deal with. And the detectors need to be rugged and be able to withstand the environment without corrosion, water ingress. All of the detectors that we tested have the ability to detect 0.3 millimeter, or sorry, 0.3 meter fire at 33 meters. So this is the requirement of EN 54, FM Global Classification Societies. And this is the standard of a 0.3 meter heptane fire at 33 meters. All the detectors that we tested have optional video cameras, and the cameras have the capability of ONVIF-S, which is a global communication standard for IP video cameras, so they can integrate with the existing NVR. Only the flame detectors, the triple IR flame detectors technology has standards at class and approved by class and included in the FSS code. The IR3 flame detectors and the thermal radiometry cameras have technology that can integrate with water cannons for automatic integration, automatic operation to point the water cannon at the fire. When a fire is detected, flow the water. Cost differences between the technologies. Thermal radiometry, due to the imager, has the highest cost. The combination video analytics thermopile is next lower. Then we have triple IR multispectrum flame detectors, and then video analytics. All detectors will be affected by water spray, so we recommend that the detectors be angled downward to avoid buildup of water on the lenses. And each detector must have alarm and fault relays on board to make sure that they can be connected to the fire alarm system. So, as far as coverage is concerned, each of the blue quarter circle represents a detector coverage. So that would be a detector located above the vehicles as high as we can get them, so we can look down between the vehicles with a 33 meter coverage. It's recommended to have some overlap in areas that might not be covered by each detector, covered by another one. The coverage is three-dimensional, so you have normally a 90-degree horizontal and a 75-degree vertical field of view. The setup that we have now on the aft deck of a RoRo ship, we have the detectors mounted, monitoring the aft deck monitoring the ship's operations to assure that we don't have false alarms, monitor the detectors for false alarms, and then we have run some testing. We've got some more testing coming up for the detectors. So triple IR multi-spectrum flame detectors have been used in the marine market, oil and gas market for years. They do comply with the FSS code. All classification societies have multi-spectrum infrared standards and approvals. EN54 has standards, FM Global in the US as well. So these are widely used on refineries near the ocean, on offshore oil and gas platforms, FPSOs. So the way that triple IR flame detectors work, they're monitoring for the IR signature from hot CO2 that is a byproduct of an organic fueled flame. This technology was the fastest to detect in the lab tests. So the way that the system works, as you can see in the top image, so the top is a Fike, the bottom is a Tycho. They work very similar in the fact that they are monitoring for the 4.5 micron spectrum. There are 3 ports. The 4 and the 5 microns are reference bands. If we see a high incidence of 4.5 and low of 4 and 5, then it is likely a flame. But if we see a high signature of all the frequencies, then it's likely noise. So that's basically how a triple IR flame detector works. There's more in the algorithms based on the manufacturer. So pluses of video analytics, pluses of triple IR multi-spectrum flame detectors. They've been used for decades on marine vessels, primarily in the oil and gas industry. There are approvals in place. They're compliant with FSS. Low to no false alarms. There's no reason why this technology should have any false alarms in the environment. Very fast detection as well. Minus, as with any of the detectors, if the lens gets dirty, that would inhibit the detection. The detector should send a signal to the fire alarm panel if its lens is obstructed. This is a video from the lab fire. So you see the detector went into an alarm very quickly, and the flashing outline indicates an alarm situation. Same situation on the aft deck, a gentleman holding a rag on, a stick with a rag on fire. Same flashing indicating the alarm. So the thermal radiometry cameras monitor the outside surface of objects in the camera's field of view. They have been proven to detect at very great distances. A lot of potential for this technology to be used in the fire service, both on land and in the marine environment. There are few approval standards now, and this technology is just becoming to be used for the fire service, but we're seeing a lot of good results from the technology. One of the issues that we run into is when you're loading and unloading, the hot engines are picked up as a high temperature on the thermal cameras. So we must set the alarm threshold above the hot exhaust pipes, or turn off the detectors during loading and unloading. The way that the technology works, we're monitoring a higher frequency than the triple IR. The energy is transmitted or received on an imager and then processed for alarms, and video is displayed. So these are some images of thermal radiometry cameras monitoring battery energy storage containers. There was a thermal runaway event inside the container, and you can see where the on the thermal side where there's a floating crosshair, little X, that's indicating the pixel with the highest temperature. Very useful for this application. So this technology has been used for years for security, monitoring for people, for vessels, on board ships. It will detect a hotspot prior to a flame, which a triple IR flame detector or a video analytics camera requires. Has long range capabilities, and we're starting to use it for fire detection. No FSS or other standards for this type. We do see some high false alarm rate during loading and unloading, so some tweaking of the technology needs to take place, and this is the highest cost detector. Video analytics is monitoring light levels. Sometimes some technologies use color. We're looking for dynamic flicker and the movement of the flame, the shape of the flame. So this works best on large fires, especially at greater distances. And the detector needs to see most of the fire so we can see the flicker and the moving object. It is being used on oil and gas platforms currently. A video from our lab tests, the video analytics will indicate the area of the flame with a red box. So pluses, the technology has been used in the marine market on oil and gas facilities outdoors, has proven to have a low false alarm rate. Minus, no EN 54 standards or other marine approved standards for this technology. FM Global in the US does have a standard for video analytics. Need to have the full flame in the detector's field of view. Obstructed flames likely will not be detected. You have to see the full flame. And wind can affect the flame and how it's perceived by the technology. The combination detector is video analytics with a thermal pile. It's not as advanced thermal radiometry as a thermal camera, but it will tell you if there is heat in the area of the detection. So we're combining, if the video analytics sees a flame and it's confirmed by heat in that area, then alarm is generated. There are no standards for this technology. This is new to the market. It shows promise. We're doing some testing. It has detected. We have seen some false alarms with it. But with video analytics, the wind can have an effect, and small flames will not be detected, where they likely would be detected by thermal cameras or the triple IR flame detectors. So based on the testing on the ship so far, the thermal radiometry cameras have been challenged as we expected them to be due to the loading and unloading on the vessels. The combination as well, we are seeing some false alarms. Video analytics can be affected by sunlight, flicker with water on the deck, and then if there is some heat in the area, that can cause a false alarm. The triple IR flame detectors and the video analytics have had no false alarms to date. So thank you for your time.
Many thanks, Rick. And I recall early days at the IMO when we had deliberations on these things, and there were a lot of concerns that the detection systems just weren't there. But I think the industry has caught up, and there seems to be quite a lot to choose from. Moving from detection to the final part of our general discussion here is on the suppression side. So Roger, how would you recommend we deal with this in case we have a fire on the weather deck?
Yes, can you see my presentation? I don't think so.
Not yet. Let's give it a second.
Not yet. Just a moment, because I had clicked to share it.
While you sort that, Roger, I can just remind the attendees of the opportunity to put questions in the interface. You have a questions button there you can just type in. So you're up and running now, Roger, please go ahead.
Okay, great. So yes, hello everyone. My name is Roger James, and I'll be talking about fire suppression on weather decks. I am the Director of International Sales for Unifier of Sweden. This is the problem we're addressing, which was laid out, I think, well for everyone. I have a lot to cover, so I'm going to go through these fairly quickly. First, I'll give an introduction of sort of some of the takeaway conclusions from the research and development we've done in the LASH fire context. I'll talk about then the objectives that we were given, the solutions we came up with. I'll talk more about the fire monitors themselves, and then we'll get into, I'll show some photos from large-scale testing that we did for the suppression, and then also of autonomous systems. And then I'll wrap it up and conclude again. So some of the takeaways. First of all, one small 2-inch remote-controlled fire monitor, as you see here, with a modest flow of 1,250 liters per minute at 5 bars, can effectively suppress and contain a large fire. The primary goal is to suppress and contain, and then of course, if we can extinguish, all the better. Also, 2 fire monitors fighting simultaneously from opposing angles is much more effective, and in some tests we're even able to extinguish large fires. Next, because the systems are relatively small, using a 2-inch monitor at relatively low flows and pressures, we're able to reduce the costs. Smaller pipes are required, smaller pumps, and so on. So that keeps costs under control. Next, rapid intervention is really key. So we want to minimize the time to detect and then commence suppression as much as possible. Also, autonomous systems can very rapidly detect a fire, locate the fire, and suppress it with the fire monitors. This brings a big advantage to be able to react very quickly to a fire on the weather deck. So the objectives that we looked at were, first of all, quick system activation and suppression. Then also the safe controlling of the monitors by remote control. Next, high coverage of the deck. And then all of the equipment needs to be able to withstand the harsh environment. We want to also minimize cost to the maximum extent possible. And we also want to bring in state-of-the-art technologies to help with the problem. So the solutions that we came to and developed and tested were fire monitors, so remote controlled, also looking at semi-autonomous and fully autonomous remote control systems. And then we also, another partner developed a compressed air foam system, which unfortunately during the testing malfunctioned, so we don't have any conclusions from that. And for that reason, I won't talk about that in the rest of the presentation. So looking at the fire monitors, we are recommending 2-inch remote controlled monitors. They should be made, obviously, of a material that's appropriate for marine environments, such as stainless steel 316L or other equivalent. We are recommending a modest flow of 1,250 liters a minute at 5 bars of pressure. And again, that's to keep all of the system requirements down to a minimum while still being able to provide effective suppression. All of the monitors need to be, as we're recommending, not the IMO anticipated language that was introduced at the beginning of the talk, but from our research and development and what we're recommending to the IMO through the LASH fire project is that the monitors all be able to be remote controlled. And there's a number of reasons for that. First of all, by having them remote controlled, you allow the maximum flexibility in terms of placement, to put them up high and in locations where they can adequately suppress a fire on the weather deck, especially given the very tight packing of the cargo. Also, you can have a faster response. A human can pick up the remote control and immediately start suppressing, rather than having to get to a mechanically operated monitor very often to get dressed and air supply and so on and so forth, which dramatically reduces the response time. Also, from a safety perspective, to be able to keep a safe distance away from the fire and still be able to operate that. And then by not requiring these structures to get up to a physically manually operated monitor, and for the other reasons, we're able to lower the overall cost. So we're recommending that all systems be remote controlled, as I just mentioned, but also we have looked at and developed and allowed for semi-autonomous systems, which allow a human to start the system, but be able to record and play back a spray pattern while they continue on to other suppression activities or help with other emergencies. Also, fully autonomous systems that require no human intervention whatsoever, which can automatically and very quickly detect a fire and suppress it. We also are recommending that all locations of the deck be accessible by at least 2 monitors positioned at opposite sides of the deck, and that the fire pump be able to supply at least 2 monitors simultaneously. Also, the monitors should be placed high up in order to give them the ability to properly suppress the cargo, including in the middle. As you can see, as you know, the decks get very packed, and you need to get them up above them to have any sort of an angle of attack to suppress them. So now I'll go through some of the tests that we did. Essentially, we did a large-scale fire test to see the effectiveness of the suppression with water. And we did different combinations. So we did them with 1 monitor at a time, and then we did 30-second pre-burn to simulate a rapid autonomous response. And then we also did a pre-burn of 300 seconds or 5 minutes to simulate a sort of a human intervention with a 5-minute delay, and see how the system was able to, or how the monitors were able to suppress a fire under those conditions. So we did that with 1 monitor, and then we also did it with 2 monitors at different angles, and again with different delay times. And then in a separate set of tests, we looked at validating an autonomous system to see if it could detect and aim, and I'll get into that also. So the setup was really to mimic a freight truck on a weather deck and sandwiched between 2, in this case, containers, but to simulate also 2 other freight trucks. This was the actual setup, and these containers contained many thermometers inside to measure the tests, the temperature buildup, and so forth. There were 224 pallets in each of these tests, so they really led to massive fires, plastic pallets on the top, and then idle wood pallets beneath. The monitors were mounted up high according to the recommendations. Here's a view from behind one of them looking down at the test scenario. So now I'll show you a few pictures of 1 monitor, and in conclusion, 1 monitor in all of the tests was able to effectively suppress and contain the fire, which is our primary goal. And you can see the pre-burn times led to the 300 seconds especially led to an absolutely massive fires. Very, very interesting results and very effective suppression. And I have a video, and I'll be happy to share links with that after the webinar. Anyone who's interested can see that on LashFire and on our website as well. Just some more images of the single test, single monitor. And then here's several images of the 2 monitors. And in conclusion, with 2 monitors, we saw far superior suppression, much more rapid cooling, and just an overall much better response. And in fact, several of the tests with the 2 monitors were able to actually extinguish a very large 300-second pre-burn test very quickly. So very, very effective with 2 monitors. Again, to summarize, 1 monitor is successful, able to suppress a fire, but not able to extinguish them. Still, that's a success in terms of what we're after. Early intervention was much better than later intervention. So the sooner you can get to it, the better. Also, tests using the 2 monitors was superior to all of the tests using 1 monitor. And again, the early intervention, 30 seconds, was much better than 300 seconds. Now, turning to fully autonomous systems, we tested, so Unifier developed the Flame Ranger system, fully autonomous system, that is essentially combining the fire detection with the aiming of the water monitor by means of using advanced electronic hardware and software. And the technology is really coming a long way on the market, and these systems are now becoming more and more ubiquitous and becoming more and more advanced. The basic idea is you bring in signals from a fire detection technology, and various technologies can be used, including the ones that Rick Jeffress mentioned earlier. So you want to detect, you want to be able to locate that fire, you need to know where it is. You then want to aim the fire monitor autonomously and suppress that fire all within seconds. So that's what the objective of these tests was, to see if an autonomous system on a mimicked weather deck is able to quickly detect multiple separately placed fires, able to determine the 3-dimensional position of the fires, and able to accurately guide the water stream to those fires. So the setup was a 30 by 50 meter area, again, mimicking a weather deck. We had 2 systems set up on opposite sides, and each system had 2 flame detectors in order to be able to locate the fires in 3-dimensional space. And then fires were placed at different areas on the grid, and a number of tests were conducted. This is what the monitor and the detectors looked like. We used remote-controlled gas burners to simulate the fires and be able to turn them on and off in different locations. And there was also a wind machine to simulate wind and rain and fog to see the effects on both the suppression and also the detection. So again, fire detection testing to see the time and detection accuracy. Then also the precision of the ability to aim the monitors and accurately move from one fire to the next. And then also to test the operation of 2 independent systems simultaneously, and then to look at the influence of wind on the water stream and also the influence of rain and fog on the fire detection. And this is what the actual test looked like. And again, we have video of that that we can share with you if you're interested. Very, very interesting tests and how the system was able to move from one to the next. Here's the wind machine and what that simulation looked like. And the results were as follows. So in all of the tests, in all fire positions, the system was able to detect in under 10 seconds. The fire detection was not affected by the simulated rain or fog. The system did accurately find the 3-dimensional size and position of every fire. The system accurately aimed the water streams of the monitors to the fire's locations. The monitors oscillated over the fires to provide water over a larger area than the fire itself using intelligence. The system moved from one terminated fire to another newly ignited fire in under 10 seconds. In the test, the test with 2 systems show that both systems were able to hit the fires, and that the flow of 1,250 liters a minute at 5 bars of pressure was enough to get to the area, the very corners of the test area of roughly 40-meter reach. And then last, wind will affect in relatively short distances, it didn't affect it too much, but in actual conditions, the wind will affect the stream, especially the farther away it is, and therefore, by having two monitors covering all positions, you're not only getting much better suppression, but also maximizing the chance of being able to suppress that fire even in high winds. If wind's affecting one, the other one should still be able to hit it. So just to conclude, they should be remote controlled. Two monitors should be able to cover the whole deck at relatively modest flows and pressures. Costs are reduced by having them remote controlled and relatively small. The faster we commence suppression, the better. And autonomous systems are now available that can rapidly and autonomously detect a fire and suppress it, which gives big advantages in terms of getting to that fire rapidly for a relatively low additional cost. So that's it. Thank you very much, and I'll turn it over now.
Thank you very much, Roger. Really interesting. And I'd like you to stay on, actually, because I have a question for you, and I'm going to ask the same to Martin later on. When I opened this webinar, I said that we were concerned with retroactive requirements because the ships simply haven't been built to that new design standard. So in your experience, how many of the existing ships that will have to retrofit can do that effectively with the current pump and piping capacity? And how many would have to invest in order to achieve what you have set out to do?
Yes, well, that's a very good question. Difficult, really, for me to answer. The pumps on board are likely going to be already sufficient because, again, we're talking about a very modest flow and modest pressures, and we've specifically suggested that in order to keep the requirements as low as possible in terms of the pumps and also the piping. The cost is difficult to say. I think it will really depend from ship to ship. I know that we will be providing in the public reports later this year as we're concluding the LASH fire project. That will all be, the cost of the various components and so on will all be laid out there and available. So that will become public. And I can, yeah, well, all that information will be available. It's hard for me to say, really. Every ship will be a little bit different. That's really about the best I can say.
Yeah, but you think, because the discussions we had with the member states, we came down to, with a retroactive requirement like this, if every RoPax ship does the best it can, that will actually be good enough for the flags, so that there will be no sort of very onerous requirements to change the piping and pumps, etc. My question was more pertaining to, if you have a standard installation today, will that be enough? Or if you want to be a bit more diligent, would you then have to go the extra mile? But that's a question we can actually put to Stena and Martin, because you have already done this on a few ships.
Yes. Thank you for letting in. Yes, we have actually installed water monitors on now all of our owned vessels. The last 3 is just about to get installed, and we did, to my knowledge, we did not invest in extra pump capacity in this process on any of the vessels. So we have assessed the situation and come to the conclusion that we will do with what we have. But having said that, I mean, since this is additional water application in a situation where we for sure regard it as very valuable, it might be that for some ships we will be on the limit, even if the flag states would be happy, according to what we now will soon agree into IMO. So there's nothing wrong in looking into it, even if we are not required to do so by the flag state, just to be sure that it works also in practice. Because for sure, 4 extra water monitors, for example, in simultaneous operation on the weather deck will take some water capacity out of the system.
Thank you. And while you have the floor, I could actually put a question to you that came from Paul Nichols. Any considerations on the challenges from electric vehicles? And if you maybe divide that into weather deck scenario and a closed or open rotor space scenario.
No, if we link that question to the monitors, I mean, for sure, this is a highly valuable suppression system in terms of electric vehicles, since you can apply large amount of water locally from a long distance without being present as a crew. So it's a very valuable asset. We have several vessels, for example, where we have the top deck being a passenger car deck, and having these monitors there will be an asset, especially for electric cars. Yes.
Very good. Thank you, Martin. Looking at the time and considering that we have covered all the bases, we don't have any unanswered questions here in the chat. I would like to take the opportunity to thank everyone for your contribution and for calling in. This will be presented on the LASH Fire website, as I said before, together with the presentations and the videos that we were talking about, that what you were referring to. So with that, thank you very much to all and have a nice day. Bye-bye.